Galileo Galilei first studied gravity's effects on rolling objects in 1602, observing how balls of different masses rolled down inclined planes, sparking a curiosity that would change our understanding of the universe forever. His experiments laid the foundation for a new era of scientific discovery, challenging conventional wisdom and paving the way for groundbreaking findings. Gravity pulls objects towards each other, with a force proportional to their mass and distance. Sir Isaac Newton later developed the law of universal gravitation in 1687, building on Galileo's work. Gravity's effects are crucial to understanding our universe, from the motion of planets to the falling of objects. The ball rolls down the ramp, accelerating at 9.8 meters per second squared. Measuring the time it takes for the ball to roll down the ramp helps calculate its velocity and reveals gravity's impact. With this data, Sparks can now apply the concept of gravity to real-world problems, like designing safer roller coasters. Understanding gravity's effects on rolling objects has numerous practical applications, from transportation to entertainment. Gravity's force is proportional to mass and distance, but what's causing this discrepancy? In 1971, the Apollo 15 mission demonstrated gravity's effects on the moon's surface, with a similar ramp experiment. By applying the concept of friction, Sparks can better understand the toy car's motion and gravity's role. Gravity is key to our universe, governing planet motion and falling objects, as outlined in Newton's law of universal gravitation. In 1687, Sir Isaac Newton published his law of universal gravitation, revealing gravity's role in the motion of planets and objects. The ball's acceleration down the ramp is 9.8 meters per second squared, demonstrating gravity's constant force on Earth's surface. Studying the rolling ball experiment helps Sparks grasp how gravity affects motion on our planet, a fundamental force shaping our world. Gravity acts on both objects, but air resistance slows the toy car. This discrepancy sparks curiosity. In 1971, the Apollo 15 mission demonstrated gravity's effects on the moon's surface, inspiring similar experiments on Earth. Sparks discovers how friction affects the toy car's motion, revealing gravity's crucial role in the experiment. Gravity's force is proportional to mass and distance, influencing planets and objects, as described by Newton's law of universal gravitation. Gravity influences the skateboarder's speed and direction, with friction and air resistance playing key roles. The wheel's rotation and friction with the ground affect the skateboarder's motion, as demonstrated by physicist Daniel Bernoulli's principles. As the skateboarder adjusts their grip, they respond to gravity's force, illustrating the concept of center of mass, studied by physicist Archimedes. Sparks realized that gravity's force is proportional to mass and distance, as demonstrated by the Cavendish experiment in 1798. Gravity's effects are visible in Jupiter's orbit around the Sun, taking about 12 Earth years to complete. By understanding gravity, scientists like Neil deGrasse Tyson can better explain the universe's mysteries, like the formation of black holes. Physicist Ernst Mach studied gravity's effects on falling objects in the late 1800s. In 1798, Henry Cavendish measured the force of gravity between objects, revealing its dependence on mass and distance, a fundamental principle that still guides our understanding of the universe today. Astronaut David Scott demonstrated gravity's effects on the moon's surface during the Apollo 15 mission. Planets like Jupiter orbit the Sun due to gravity, with Jupiter's orbit lasting about 12 Earth years.